Alright, some solutions to the word problems that we went over in class today. I'll kind of fire through these a little bit quick, since hopefully you got a good idea of how to do them today. See, this first one, we want 3 consecutive even integers whose sum is 300. So if we let x be the first of these guys, then the next one is going to be x plus 2. Right? Since it's even, it's got to be 2 bigger than our first one. And the one after that would be x plus 4. And what we want is the sum of these three guys, x plus 2, and x plus 4, to equal 300. So if you combine like terms, we got 3 x's over on the left here, plus 6 equals 300. So we can now solve this by subtracting 6 from both sides and get 3x equals 294. And if you divide by 3, you get x equals 98. But we just solved for x. We want to know what the 3 consecutive integers, even integers, are. So since x was kind of the first of them, it's going to be 98, this guy would be 100, and this guy would be 102. So our final answer would be something like 98, 100, and 102. Alright, moving on to the second one. Find two numbers whose sum is 24 and product is 135. Okay, first let's worry about the sum here. If we let x be one of the numbers, then the other number has to add to x to get to 24. That is, the other number has to be 24 minus x. Right? If x is 4, we need them to add up to 24, so the other number that's in parentheses here would be 24 minus 4, or 20. So these two numbers, x and 24 minus x, need to have a product of 135, meaning when you multiply them together, it's equal to 135. So we've set up an algebraic expression here. We can solve it by distributing the x through. Get 24x minus x squared equals 135. I'd like to have a 1 as my leading coefficient in front of my x squared term, so maybe I'll add this x squared over to this side. And then I'll subtract this 24x over to this side. And then I still have the 135 on that side. And that's all equal to 0. And then here's an expression we can solve. Let's see, we can complete the square or use the quadratic equation. But I think this one will actually factor for us if we take the time to figure out what works here. See, we need two numbers that multiply to be 135 and add up to be 24. And that's a little bit hard, maybe a little bit too big of numbers to do for a quiz or whatever. But if you play with it long enough, I think what you'll figure out is the two numbers end up being 15 and 9. If you couldn't have come up with that, at least you can check my work, right? You could FOIL this back out and make sure that you do, in fact, get up here. And I think you will. So anyways, now we have something times something equals 0. So we could say either x minus 15 equals 0 or x minus 9 equals 0. So we got either x equals 15 or 9. You might be confused, why do we get two answers? Well, because we didn't specify which one we're talking about, right? If we choose 15 to be our x, then the other one is 24 minus 15, which is 9. And if we choose 9 to be our x, then the other one is 24 minus 9, which is 15. So either way, the two numbers are 9 and 15. All right, number 3, the length of my office is 50% bigger than the width of my office. So maybe we'll let W be width. So W equals width. And since the length is 50% bigger than the width, we can say 1.5 times W is equal to the length. And what's nice here is we only have one variable, and we know that the perimeter of the office is 60 meters. So maybe it's worth drawing a little picture of the office. Let's see, this is the width over here, and the length is 1.5 times the width. And we know that the perimeter, the way all the way around here, has got to be 60 meters. So that is this plus this plus this plus this. So let's see, 1.5 plus 1.5 more gives us 3, 4, 5. So 5W equals 60 meters. Divide both sides by 5 and you get that the width is 12. Okay, if the width is 12, we can figure out the length. Let's see, maybe I'll put that up here. The length is 1.5 times the width. So 1.5 times 12 ends up being 18. So we got the length and the width, although the question seems to be asking for the area. But area equals length times width. So it's equal to 12 times 18, which is probably good enough to just leave it like that. But if we really want to figure this out, let's see, 10 times 18 is 180, and 2 times 18 is 36. So 180 plus 36, I think it ends up being 216. I'm not too concerned with units, but if you really care, I guess that would be meters squared, because we're talking about meters here, but area is a square, length times width. All right, number 4. A friend and I start at the same spot. Maybe we start right there and start running. I run east. See, that's this way. And she runs south this way. If my speed is 75% of her speed, so maybe we'll let her speed be x. And after 2 hours, we are 10 miles apart. Okay, so this distance right here is 10. Let's see, after 2 hours, if her speed is x, her distance is 2 times x, right? Distance equals rate times time. Time is 2 for 2 hours. Rate is x, her speed up here. And then we can figure out what my distance, the distance I've ran here is. Again, it's 2 hours times my speed. Well, my speed is 75% of x. So 2 times 3/4 of x, which is the same as just saying maybe 3x over 2 or 3/2 x, however you want to write that. So we have this triangle here, and what's nice is it's a right triangle, so we can use the Pythagorean theorem, and that says that this squared plus this squared equals this squared. So 2x squared plus 3/2 x squared is equal to 10 squared, which is 100. 2x squared, be careful here, you want to square both of these guys, right? Remember our exponent rules. So that would give us 4x squared. If we square 3/2, 3/2 times 3/2 is 9/4 x squared equals 100. Let's see, we want to add 4x squared and 9/4 x squared, so we should get a common denominator. 4 is the same as what, 16/4? So 16/4, maybe I'll write that, 16/4 x squared plus 9/4 x squared equals 100. And on the left here, 16 plus 9 is 25/4 x squared equals 100. So if we multiply both sides of the equation by 4 divided by 25, let's see, maybe we'll divide by 25 first. That gives us a 4 over here. Then multiply by 4 and we get 16. We'll get x squared equals 16. So finally, if we solve, take the square root of both sides, we get x equals plus or minus 4. But we don't want it to be minus 4 because we're talking about speed here, right? We wouldn't want to say she's running negative 4 miles per hour. So we'll just take the positive answer here. And how fast is she running? She's running 4 miles per hour. All right, moving on to the last problem. Not a whole lot of room here. The fence problem. It takes me 20 hours to paint a fence. It takes someone else 15 hours to paint that fence. How long would it take if we worked together? The trick to this one is thinking about it as a distance equals rate times time problem, where the distance, maybe this needs quotation marks, would be one fence, and the rate, maybe my rate, is saying, let's see, it takes me 20 hours to paint a fence, so my rate, my speed of painting here would be 1/20th of a fence per hour. Fence per hour. You don't need the units, but I'm just putting them in there so you can, maybe it makes more sense to you. So we got my rate. We can figure out my friend rate. Just get parentheses again, quotation marks, I guess that is. Let's see, she takes her 15 hours to paint a fence, so she paints a 15th of a fence per hour. And once you translate it to these terms, it's not as bad. It's like we paint at this speed and she paints at this speed, so our together rate would be this speed plus this speed, right? The speed that I'm painting plus the speed she's painting. So that's 1/20th plus 1/15th. It'd be nice to simplify this. Let's see. Maybe instead of 20, we can think about that as 5 times 4. And instead of 15, we can think about that as 3 times 5. So to get a common denominator, let's see, over here we're missing a 3. So we'll multiply by 3 over 3. And over here we're missing a 4. So we'll multiply by 4 over 4. And if you do that, we have this common denominator of 3 times 4 times 5, which ends up being 60. And then up top we got 3 over here and 4 over here, so we get 7. So our combined rate, if we work together, we paint 7/60th of a fence per hour. So if that's our rate, we want to know how long will it take to paint one fence. So it's like distance equals rate times time, but we want to know how long it'll take. We want to know what time is. But if we divide both sides by r, we get time is distance divided by rate. So our distance is just one fence, so our answer will be 1 divided by 7/60ths, or if you want 1 over 1 over 7 over 60. We know how to divide fractions, right? You flip this one upside down, you get 60 over 7 up here, times 1 over 1, you just leave it as 60 over 7. So if we work together, it would take us this long. What's that, a little over 8 hours? 8 and 4/7, I think, is what that reduces to. But it's math. I'm not concerned about the actual answer, just the practicalness of the answer, just kind of what it's equal to in fractions. So that's the last one. That's the end of the worksheet. Hope that's helpful to see some solutions.